I'm Tero, and I want to talk about directives, which are, as we all know, the kind of most powerful feature in Angular. But the reason I want to talk about directives is not because they are powerful, but because they have everyone's favorite API in Angular. So I have this confession to make, which is that I've been using Angular for a couple of years, and I still don't kind of know most of these API tweaks I can do with directives. And that's a problem, right? Because I don't like using APIs that I don't quite understand. Because you always have this feeling that whatever you're doing, you could probably do it a lot better if you only knew how. And that's not nice. So I've been trying to deal with this with different strategies. What I often try to do when I can't figure out something from the API is to go to the source, because that's sort of the ultimate truth of what something does. If you can't figure it out from the API or the docs, you read the code and see what's in there, because that's how you learn it. So if you want to learn the Angular directive system, you can go to source ng compile.js and read it to learn it. And this is what you see in there. Whoops. Any questions? So this is a problem, right? Because if you want to learn something, how do you learn it when it's this complicated? And I don't mean to disparage the directive compiler, because it's one of the most phenomenally useful software pieces I've used, because how many of us ever get to write something that's this useful and used by so many people? But it is difficult to learn. And I think the Angular team kind of fully acknowledges this fact when they say things like this. And they say that compile is a problem. And they are fixing it for 2, so that's great. It's looking great. The APIs will be simpler. The implementation will be simpler. But what we have to deal with right now is compile.js in Angular 1. So what do we do with that? So we have these applications that we built that we are running in production all the time. So what do we do with them? The strategy I've been trying to do is, instead of reading the source code, is to write the source code, to sort of force myself to replicate what it's doing by writing my own version of it. So that's what I've been doing with the AngularJS compiler, and I want to kind of share a few things about what I've learned by kind of building it from the ground up. And there are 4 things I want to focus on, which are compilation, linking, inheritance, and isolation. So 4 things that the compiler does. As we saw right there, it does a lot more than this too. But this is a big part of it. This is sort of the core. So let's get right into it. When you're talking about a compiler, probably the most interesting thing about it is the compilation that it does. And compilation in Angular means a specific thing. It means taking directives that you have registered and some DOM that you have registered, some DOM that you have on your page, combining those 2 to produce a compiled DOM, applying those directives to the DOM. That's compiling. And the way that looks like in code is that you register these directives to the compile provider. The directives have names, and they are produced by these factory functions that return objects that have all these keys that we were looking at. This one has just one, the compile function, that takes an element and does something to that element. So in this case, just adds a class to it. Then you have some DOM on your page that's decorated with attributes and stuff like that. You grab it from the page, you wrap it inside an Angular element, and you give it to the compile function and expect it to compile it for you. So how would we implement something like this? Well, we need to start with the compile provider, which is that thing that makes the compile service. As we saw, this provider has the directive method in which you register directives. And when you do that, those get stored in this object inside the compile provider called directives. That's an object where the keys are directive names, and the values are the factories for those directives. And one thing about Angular is that you can have several directives for each name. So there's no uniqueness constraint on directives. So the values in this object are actually arrays. So we have an object where keys are directive names and values are arrays of factory functions. So then we need to also plug this into the dependency injection system, because directives support dependency injection. And we can do that by pulling in the provide service that Angular makes available to us during configuration time. And then when we encounter the first directive for a given name, we produce this plain old factory function into the application that's called that directive name plus the suffix directive. And this factory function will then instantiate any directives that we have with that name. So we look the factories up from this internal object that we have in here. And then we need to call each of those factories to instantiate the directives. And we need to support dependency injection, so we use the injector, map the functions over the injector invoke function. And the result is an array of directive objects that have been created with this dependency injection mechanism. And then once we're done with the registration, we can produce our compile service. So like any provider, it's done with this get method in the provider, and that returns the $compile function that we have in Angular. So when you use $compile, here's where it comes from. And it's just this function that takes an element and compiles it. So now we can get into what compilation actually means. First of all, the compile service itself, or the compile method, doesn't do much. It just delegates its work onto this compile node function that then does all the work. This function, we want to be a function that compiles a piece of DOM for us. And that compilation process has two steps to it. One is finding all the directives that we know about that match to this element, and the second is applying those directives to the element. The first step of finding those directives is, again, delegated to a helper method called collect directives, which we expect to return an array of directive objects that we should apply to this element. And we use three matching strategies to do that. First of all, directives can be matched to an element by the element's tag name, or they can be matched by one of the element's attribute names, or they can be matched by element CSS class names. And we combine anything we find with any of those strategies, and we return a combined array. Now, there's also a fourth strategy, which is matching directives to HTML comments, but I'm not going to talk about that because it's obsolete as well as a little bit weird. But we'll look at these three. So to match an element to a directive to an element name, you first grab the element's name. You have to figure out what that is, which you can get from the DOM with the standard node name attribute. Then you need to camel case it because our directives are in camel case, and we can use Lodash for that. And then you put in the directive string suffix that we put in the injector to be able to use the injector with this. And now we can check whether we actually have some directives with this name. So we have this object here in scope, which we can just ask for whether it has a key for this directive name. If it does, we get those directives by calling the injector with the full directive name, and that will give us the array of directive objects which is produced by that factory we set up a couple of minutes ago. And we need the injector to be able to do that. If we don't find anything, we just return an empty array and we're done. So matching directives to attribute names is very similar. We just need to do a little bit more work since there may be multiple attributes, so we actually loop over them, collect the results to this array. So for each attribute name, we camel case it, put in the suffix, check if we have directives. If we do, we instantiate them and add them to our results. And then we do the exact same thing for CSS classes. So we make a result object, we iterate over the class list, DOM class list of that element, camel case each class name, and then check if we have something with that class name. And when those three functions have been run, we have the full array of directives that this element matches, that match to this element. So we can go to the second part of compilation, which is actually applying those directives. And that we can do simply by looping over them, and for each one, calling the compile function. So here's where the directive gets to do whatever it does. Our example directive put in a CSS class when you did this, but they usually manipulate the DOM somehow and do whatever they do. But before we're done with compilation, we're almost done, but we still need to do one thing, which is that usually when you call compile, you don't expect it to just compile a single element. You expect it to compile a full tree of elements that stem from this root that you give it. So we need to traverse to the child nodes of the element as well and compile them. That's actually quite easy to do because all we need to do is, for each of the children of this element, we have a recursive invocation to compile node. And for that, it'll, for each element, restart the process of collecting the directives and applying them. And at the end, you have this depth-first tree traversal, where for each node, you match the elements, match the directives, and apply them. And when you're done, you have compiled your DOM. So that's compilation. It's sort of interesting by itself, but it's not yet very Angular specific. It's basically just a glorified version of something like jQuery, where you match code to elements. But where we get to bring Angular more into the picture is when we start to talk about linking. Because linking brings in scopes. And as we know, scopes are kind of the central architectural concept, kind of in Angular 1 at least, because that's how we bring in application data and functions. We put them on scopes to share them between controllers and templates and directives. Scopes are also where change detection is implemented, because they have the watches and they have the digest. And scopes is where event propagation happens, because that's where broadcast and emit are done. So scopes really are what brings in Angular to this thing that we have with directives now. And the process of combining scopes and directives is called linking. So we'll extend our picture of what compile actually does a little bit first, because it has actually two products that it comes out with. It produces the compiled DOM as we saw, but it also produces this link function, which we can later use to link the DOM. And that's essentially another function that we use that takes as inputs the compiled DOM and a scope object and combines those two to produce a linked DOM. So there are two steps to this whole process, and what's sort of interesting about that is that there's no link service in Angular, because it's all built into compile, and the linker is sort of output from the compile process, and we'll see how that works in a little bit. So if you want to link directives, this is how you can do it, at least one of the ways you can do it. You have a link function that takes a scope and an element, and then you can do stuff in the link function with those two. So in this case, we add a CSS class to the element, which happens to be dynamically determined by the scope's attribute. So it's sort of an input to this directive. And the most low-level way you can produce a link function is to have it as the return value of your compile function, like we do here. And how you actually do linking is that you have to grab onto the return value of compile, as you call it, because that's going to be your link function. And then you can prepare your scope, which might be the root scope or some other scope, and you call the link function with that, and that will initiate the linking process. Usually this all gets done for you by the bootstrap or something like that, but you can do it yourselves, and many of us have to do it when we do some custom directives and things like that. So how does this work? We expect compile now to return something. We'll delegate that to the compile node function again. And that will return the link function that we need. So that's called the node link function. It takes a scope and is expected to link the DOM to that scope. So, and what does that mean actually? Well, it means calling all the link functions of all the directives that we have found for this element. So we have to collect those link functions during the compilation. So what we do is create this array where we put link functions, and then as we iterate over those directives and call the compile functions, we put the return values that we get from the compile functions, which are the link functions, and store them into this array. And then we have the link functions, and during linking, all we need to do is call them. So we have this loop where we call each link function for the element. So in between compilation and linking, this sort of linking is waiting to happen in this JavaScript function closure, which is sort of an interesting way to do it. But this is how it happens in Angular. Now, as we were talking about compilation, we talked about having to also traverse the child nodes. We do need to do that when linking as well, so we need to link the child nodes as well. So if we look at how we did that with compilation, we have this recursive invocation to compile node for each of the child nodes. And if we look at compile node, it returns the node link function. So in order to link the child nodes, we need to keep on to the return values of those recursive calls, because each one will return for us a node link function for each of the children. And then we just call those two as we are linking. Each of the link functions that we collected, we call it with the scope. And this is essentially the node link function recursively calling itself, even though in a bit of a roundabout way. And as you may notice, we call the child link functions before the element's own link functions. And that's because this is so-called post link functions, which you get when you don't specify one or the other. But there are also the so-called pre-link functions, which I won't cover, but that are essentially just another loop above the child link functions loop. So the difference between pre and post linking is pre-links get invoked before traversing to the child elements, and post links after. The default is post, and this is how that is done. And that's linking, though that's a little bit of a simplified version of linking, since what we did there is we had this scope that we gave to the linker, and that same scope was used for everything, for all the directives across all of the DOM elements. And as Angular application developers, you know that that's usually not what you have in your apps, because what you have is a scope hierarchy. You have this tree of scopes that inherit from each other. And furthermore, that's usually a hierarchy that sort of mirrors your DOM hierarchy, because in your DOM you have these directives that create scopes, like ng controller, that then cause this scope tree to look a little bit like the DOM tree. So how does this work? Well, any directive can request an inherited scope by providing in the configuration this scope key with a true Boolean true value. And that will get the link function some privacy, essentially. You can put stuff onto the scope that you get to the link function and be relatively sure that you're not going to mess up your siblings or your ancestors by doing that, because the scope is now your own. And how does this work then? Well, as we go over the directives during compilation, we have to check whether any of them asks for an inherited scope. And if it does, we store it in this variable. So in the directive loop, we'll check if the directive has a scope attribute with a truthy value, and if it does, we put it in the variable that we have here. One restriction, though, is that we allow only one of these maximum per element. So if we encounter one of these scope requesting directives and already saw one, we're going to throw an exception because there's no more than one inherited scope allowed per node. And then when we have that variable, when we go into linking, we can check whether we actually saw any directives that asked for a scope. And if there was one, we simply just create a new scope by calling the new method on the current scope, and then we use that scope for everything from that point on. So it gets given to all the link functions of all the directives on this node and on all child nodes. So it essentially replaces the parent node completely at this point. And here's how you get that scope tree that matches roughly your DOM tree, because these scopes come alive here and are used for the subtree from this point down. So inheritance by itself is sort of quite simple, at least compared to isolation, which is the fourth section of this. So isolate scopes are a little bit like inherited scopes, but special, in the sense that they are part of the scope hierarchy, in that they are in the scope tree, but they do not inherit any of the data or the functions of their parents. So they do not have this JavaScript prototypical inheritance going on. So they are sort of standalone, but they are in the tree in the sense that they still participate in the digest, they still participate in the events and propagate events, but they just don't have that inheritance going on. And what you do with isolate scope then, if you want to share data, is you make these a la carte isolate bindings where you say that I want this expression evaluated on the parent scope to have its value bound to an attribute on the isolate scope, and do those sort of one by one instead of doing the wholesale inheritance sharing that you get with inherited scopes. So that's the theory. The way it works in code is that you still have the scope key on your directive, which is not a Boolean value now, but it's an actual JavaScript object, which may or may not be empty. If it's not empty, what the contents represent the specifications of the bindings that we want to make. And the bindings work such that the values in that object refer to attribute names on the node where you actually apply the directive. And the keys become the keys in your actual isolate scope when your directive is linked. So those match up one to one. And the net effect of that is that you have attributes on the isolate scope that have the values from the parent scope's expressions as defined in the DOM bound to them. And that's how you can get this data into the isolate scope directives, even though there's no inheritance going on. So let's make that work. We again need to introduce a new variable during the compile node function invocation, where we store any isolate scope directives that we see. So when we have a truthy scope value, we check if it was actually an object or just some other truthy value. Because if it's an object, it's going to be an isolate scope directive. If it's just some other truthy value, it's a regular inherited scope directive. And that affects which variable we put it in. And we still only allow one of these per node, so you can use either inheritance or isolation in one element, but not both. And then when we get into linking, we again can see whether we saw an isolate scope directive. And if we did, we're going to make an isolate scope. So we put it in this variable. We can get it by calling the new method again in the scope and passing it the true Boolean value, which says, please isolate this scope. And here's where we start to see the first difference between an inheritance and isolation. And that's that when you have an inherited scope, it gets used for everything starting from when you create it. But isolate scopes don't work like that. They are only used for the link function of the directive that asked for the isolate scope. And any other directives that we might have on the same element or child elements are not part of that isolate scope. So we need to know, as we iterate these link functions, which one was the isolate directives link function, and then give the isolate scope only to that one. So in order to know that, we need to put some additional information to these link functions that we create here, which that we add an attribute to each of them, which points to the directive that produced the link function. And then when we do linking, we do call these link functions. We compare, is this the link function from the directive that's actually the isolate scope directive? And only if that's the case does the link function receive the isolate scope. All other directives will not so. Here's how you do this kind of thing where you just use the isolate scope for exactly one link function or exactly one directive and not anything else. So here's how you make isolate scopes and how they get used, how they get actually fed into the directive link functions. But the thing about our current isolate scope is that it's completely blank, right? Like there's nothing in it yet, which can be a useful thing, but often you also want to have these bindings on it, as we talked about earlier. So how do we make those happen? Today I'm going to concentrate only on one of the binding strategies, which is this equals sign, two-way binding, and the other strategies are also interesting, but I won't cover them today. Just this one. So what do we do? Well, when we create that isolate scope during the node linking, we need to set up the bindings as well. So what we need to do is go over the scope definition object and see what's in it. So we make a loop where we go over that scope where the values were those binding specs, and the keys are the keys that should be put on the isolate scope. And what we expect that spec to be is a string that begins with the equals sign and is followed by the attribute name in the DOM that we should be looking at. So we extract that attribute name from it by matching it to a regex that begins with an equals sign and is followed by any characters that we grab into a capturing group, and then we get the group's contents from the match result. And that gets us the attribute name that's specified by that scope spec. That's going to be a camel-cased attribute name though, whereas in the DOM we don't have camel-cased attribute names, we have hyphenized attribute names, so we need to denormalize it. For that we happen to have this beautiful new Lodash 3.0 kebab case function that does exactly this, just came out, I think, a couple of weeks ago. So now we have the attribute name, and we have the element up in the compile functions definition. So we can look up the attribute value from the element, and we'll do that by just calling the adder function on the element. That gives us the expression that was defined in the DOM, the attribute's value. And our job now is to evaluate that expression in the context of the parent scope, get the result, put it on the isolate scope, and keep doing that whenever the expression's value changes over time. And for that, we happen to have the exact tool that we need in watches. So we can watch that expression. We watch it on the parent scope, evaluate it there. Any new value that we get for it, we put on the isolate scope with the name that was specified in the scope spec. And here's how we can bind the expression from the parent scope to the isolate scope. But there's one more thing that's related to this that we need to talk about, which is that if you've ever used the equals sign binding, you'll know that it's a so-called two-way binding, which means that we need not only to get the parent expression's value and put it on the isolate scope when it changes, but we need to also look at changes in the isolate scope's attribute and propagate them up to the parent when there's a change. That's what two-way binding means. So we need to do that, but we can't really do that with a watch only, so we need to get a little bit creative about doing that. The first thing we need to do is we have this expression string. We need to parse it to get the actual expression function that we can call. For that, we need to use the parse service that comes with Angular, the $parse function. So we inject that into our compiler. And then we'll use it, give it the expression string, and that will return us the expression function that the string represents. And next we'll make a sort of alternative implementation for this watch that we have here. This is going to be a little bit of a special watch in that it actually doesn't have any listener function attached to it. It's just a standalone watch function, which from the purposes of the scope is just some function that it calls for us on every digest, but we use it to hook onto the digest loop and do some custom work in it. The first thing we do in it is evaluate the expression to get the value that the expression has on the parent scope at the moment. Then we look at what the isolate scope has at the moment, and then we compare those two to see if there's a difference. If there's a difference, we have to put the new value on the isolate scope. And this is actually functionally equivalent to what we had earlier with this old watch. So these watches do the same thing at the moment. It's just that the new one is a little bit more low level. We do our own change detection in it so that we can soon build the two-way binding on top of that. But we no longer need that old watch here, and now we're ready to do the two-way data binding. So what we need to do is when we see that the parent and child values do not match, we need to determine whether that's because the parent value has changed from the last time or that the child value has changed from the last time. And in order to do that, we need to introduce a new variable called parent value here in this function. And that's a variable that will always hold the latest value we have seen on the parent scope for that expression. And we introduce it outside of the watch function so we remember the latest value between digests. And then when we see that the parent and child values do not match, we can see whether actually the new parent value is the same as the old parent value or not. Because if those two are not the same, that means the parent expression's value has changed. And we need to do what we did earlier, which is to put the new value on the isolate scope. But if those two are the same and the parent and child values still don't match, that must mean that the value on the isolate scope has changed. And here's where we do the two-way part. And this is why we injected in the parse function. Because now that we have the expression function, we can call this special method on it called assign, which, given a scope and a value, evaluates that expression in a special way that doesn't give you the current value of the expression, but actually goes on the scope and reassigns that value to something new. So if you have an expression like foo.x, calling assign on it will find foo from the scope, reassign the x attribute on it to this value that we give it. This is all work that the expression parser does for us. It gives us this method on expressions, and we can use that from the compile function. And then finally, all we need to do is replace our parent value variable, because we need to be ready for the next digest when we need these things to match up again. And that's how two-way binding works in isolate scopes. And that's what I wanted to show you today. So these are some of the core things that the Angular compiler does. I think it's useful to know these things when working with Angular because it helps you kind of think about what it's doing under the hood. And of course, it does a lot more, but hopefully if you want to explore, compile further, you'll now have something in there that you recognize, and you can kind of use that as anchor points to whatever else you want to look at, transclusion or templates or whatever. And if you're the sort of person that likes to get into this sort of stuff in excruciating detail, this is what my book is about. So in the book, I build up Angular from scratch, from JavaScript and Lodash, and in the process, build up the mental model of what's actually inside there. So I've done scopes, expressions, dependency injection, the compiler, and soon promises. And actually, since you are in this conference, when you leave here in your bag, you will have a little flyer that has a code in it, which gets you this book for free. So I hope you enjoy it. Thank you.